Today we're going to talk about the TempleOS command line. Okay, so the command line feeds into a C compiler. It's not C, but it's close. So let's U0 count. I'm entering a function. Creating a 64-bit integer variable for I equals 1, I less or equal n, I plus plus. Now, there's a shortcut to doing a print. Any string by itself is a printf. Okay, so there, we made a function. So any function gets compiled and placed into memory, there's a symbol table. You can kind of think of it like environment variables. This is our symbol table. When this task started, it did some startup, and it compiled count. Now, any statement outside of a function executes immediately. So if I say count 10, so this function, this is kind of like a Commodore 64 that had BASIC, that you could enter a line number and it would stay in memory. That's like the count. Or you could enter a without a line number and it executed immediately. So it's just somebody explained it like a Commodore 64 but with C instead of BASIC. So there's a autocomplete. This will, you can say man dir. So this is the source code for the directory command. It has a U8, that's a 8-bit ASCII for the mask, and then it has a flag for full. Oh, you know what? Holy shit, this is bad. It actually has defaults, but that's in the header, not in the declaration. It has defaults in the header. I can't believe oh well. So dir star comma true. This is for a full listing. Now there's default arguments from C++. So we can say dir demo star, and I'm going to use the default for the true. And it was false, actually. That was a full listing or a abbreviated listing. Now we say, I should call it verbose. Oh, anyway, now dir, there's actually, that default is star. So if we do this, we get dir star. Now, you know what? I took a look at that and I said, wow, what if I got rid of parentheses when there's no arguments? No problem. So I changed the syntax. Now, the question is, what are the side effects? And the side effect is when you do a Q sort, you have to pass the address of a function. Now normally you say, I don't know, and then you say compare. And then it knows that that's the address of a function. But in our situation, what if we passed it dir? Now what, wait a minute, that could be an execution. So what I had to do, whenever you pass the address of a function, you have to say address of function. It makes, this is so much better, it makes you wonder what the hell they were thinking. They did not have divine intellect when they created it. Anyway, this is divine intellect. So let's take a look at what's happening when we do a directory. What does it do? It allocates some, it calls malloc to allocate some memory. It puts some code in the memory. There it calls the directory command. Now, as it turns out, the that's using the default string. Let's say dir star. Now look at that. That's 7FDHCEA5. Do you notice that's right after the return? Whenever you create a unassembled function count, this is like the basic sitting in memory. Now there was a, you remember I said %D character turn? On most compilers they have data area and they have code area. This is code. Basically it allocates a chunk, it calls malloc and allocates a chunk of memory and puts the data right afterward. So this uses register variables. I don't use the 64-bit API, ABI or whatever. I don't pass parameters with register variables. All the parameters are on the stack. All the arguments are on the stack. And as a matter of fact, I use the return pop. I didn't even know about this until several years ago, a few years ago. So it pops the arguments off the stack for you. That's kind of, it might be slower, but I like it. I made my decisions to keep the code looking pretty. I don't unroll loops, and generally I do it, I made my compiler make code an old school assembly programmer would be proud of. I don't do anything that makes it ugly. So that's how I made my decisions. I said, well, gee, I wonder how I optimize. Should I look in the book for pipeline scheduling and stuff? No, fuck that. I just did it like an old school assembly programmer. So I have, the code is really beautiful, and it actually is, it's pretty short code, all things considered. One of the things I do is I use the base pointer. Modern, a lot of people use stack pointer instead of base pointer, but I'm kind of old school. What that allows me to do is to climb the stack. Okay, I nuked it. On the wallpaper is all the tasks, and this has the stack. I have to get my dog. Hello, little puppy. Hello, little puppy. Hello, puppy. So it is mandatory that you use the base pointer because the wallpaper climbs the stack. Let's see what other commands we have. So when I ran the test suite, it created this demo garbage. Anyway, so let's look at the some people call this the file system. Okay, so the kernel, there's two modules compiled ahead of time, kernel.bin and compiler.bin. Everything else is just in time, and by that I mean Atom. When it boots, it starts executing. Oh, by the way, we can come up here and edit a file, and we can say hello world. Three times. Now we can say pound include. Remember, it's going into a C compiler. It knows C++. Let's do that. Hello world, hello world, hello world. Okay, so what I was doing, shut up bird, I'm going to kill that bird. That's God. I just got God on the phone. Okay, so you can shut up, bird. So first of all, it's not text. Shut up, bird. It's not text mode. Second of all, you can come up off the bottom. You can execute statements again. You can execute statements again. Shut up, bird. Shut up, bird. I'm gonna kill that bird. Shit's all over my room. Okay, so it doesn't have a command history. Shut up, bird. Doesn't have a command history when you use the cursor keys. So I was thinking about that. And in my mind, that was a big problem. So what I wanted to do was have command history. And what I did was I said, why don't we have a file? Control M is your menu. And this is a file of macros. These are common. All this is we have a language. We have, you know how HTML has ASCII underneath? Well, this is kind of like that. These are macros, so we can go to the kernel directory. This DC fill. So we went to the kernel directory and we did a directory. So putting these macros, Control M is your menu. Now, you know what? What if we put a picture on a macro? And it gets better. So these are sprites with a left macro, and remember, to start a file you include it. So now there's one other step. You remember how we said this was who this lists the variables? So we have main. We must have executed main, and we can do main again. It says hello world. Okay, and we have an I global variable. Now, if we include a file, notice how we still have that main sitting here. Now, when you run an application, you want to create a brand new terminal task and run it, and then destroy it. And so what that's known as doing is that's called a pop-up. So this plus PU That means run it in a pop-up. So this is running a pop-up, and when you exit, it gets returned. This, if you don't run, okay, I'm going to change to the games directory, and then I'm going to say pound include Eagle Dive. Now if I say who -r, oh no, all that stuff is in memory still. So that means we can even start the main. It's not called main. That's the old main that we still have. It's called Eagle Dive, isn't it? Eagle Dive. This will go to the source code. So if we say Eagle Dive, this is like the basic program in a Commodore 64. It's like a basic program in memory. Okay, so who -r. So that's why you want to run it in a new task. So as a matter of fact, there's a shortcut to including. This will run it in the same task. If we say include, now if we say who -r, we have even more stuff in memory. Now we have track and vroom. We have vroom in memory. This has sprites in source code. These are, so you saw those sprites, right? Let's take a look at those real quick. dir vroom. So let's take a look at how these are stored. Somebody thought it was a GIF. No, it's not. It's a triangle mesh, and I can show you right where the document editor just spins it. So we can go into the edit menu. Let's take a look at these as text. You might think they're stored as text, but they're actually stored as binary. We can edit as text. I didn't have this feature at the beginning. Somebody might demand that I store them as text, but we're not going to store them as text. So somebody thinks these are multiple files like HTML. No. If we look at vroom.cpp.z, this has binary, that's real binary data for the vertexes and triangles. And then once you get past the binary data, you get to the ASCII text of the file. There it is. This is ASCII text. It's actually stored compressed. When we dump it, it uncompresses it. So that's not a that some people think of it as an archive or I get all kinds of crazy ideas. I hear all kinds of crazy ideas. No, what it is text and binary in one file, and it's compressed. If you make it end with a Z, then it stores it compressed. If you want to make it uncompressed, you move it to one without a Z. There's no rename because that would screw things up. You have to do a move, and that has to recopy it. Because to compress or uncompress, it's not just changing the directory. It has to redo the file. So anyway, so does that answer your questions? What other interesting things do we have? Let's reboot. This reboots without doing a hardware reset. I just like to do that. Now it doesn't use paging, so it will fragment. It identity maps. I tried to make it kind of like a Commodore 64. So this is the BIOS report on memory. This is physical memory in the system. I have 64 gig If you look at that, that's not, wow, look at how huge that is. Each one of these is 4 gigs, so that's 13 times 4, 4 times 13. I have 52 gig. Somebody thinks I'm going to do AI or something. I don't know. Why not have 64 gig? So, so the memory will fragment. There's no question. Eventually. I've never had that problem, but even when I only had 512 meg. The minimum is 512 meg because I could explain the reason you need 512 meg and not more than 512. Well, the way the heap and memory system work. So when you free memory, there's an array of linked lists. If you free a 32 byte chunk, it goes into this linked list. If you free a 48 byte chunk, it goes into this linked list. When you request a 48 byte, it comes out of this linked list, or it gets sliced off a slab. So the nature of most programs is that you allocate a lot of 32 byte, and then you free them and you allocate them and you free them and you allocate them. Now when you're doing, let's say you copy all the files from your C disk to your D disk, I don't think it has to uncompress. But anyway, you have a bunch of 1K, 2K, 5K, 20K, and when those get freed, they get put into these linked lists. These linked lists are owned by the task. These linked lists are owned by the system. So if you free a 512, if you free a 4K chunk, it goes back into the system. Into the system pool, block pool. Goes into the system block pool. So basically, if you copy the C drive to the D drive, let's see size. I think I can say size report. So if you copy the C drive, if you copy Control O, so if you copy, then see all these size chunks, they're going to get freed and shoved into the arrays up at the top. Oh, I got rid of them. Anyway, and so you really are going to use up 512 meg. But it has a limit. Once you start reusing, it doesn't really allocate more. They just end up getting shoved into the list and they sit there. So now remember when we say directory, if we say trace, and we say let's do a report of all the symbols in numeric order. So when it starts up, it compiles the Adam directory, and that puts the Adam task is Adam and Eve. He's the first task, and all the symbols go into his symbol table, and all his children, if they don't find a symbol, they search their parents. So all the children inherit Adam's symbols. So this is an alphabetical order. So when Adam starts allocating code, you remember it's like a basic program, so it's right in his, Adam starts making basic programs in his memory space. Blocks are assigned to different tasks, so that when the task dies, it gets freed. Okay, so So notice these start at about 7F. Most people freak out and they think that's stack. No, there's not paging. There's no preordained configuration. Basically, as a matter of fact, all code goes in the lowest 2 gig. 7F is 2 gig. And the reason for that is, let's say we do a trace and then we say directory. How did it code this? So we called the directory command. So remember, I shoved it into a 7F location. So this is a 32-bit relative instruction. Now, if you're smart, you say, "Uh-oh, with 64-bit, you can't use that." The x86 only has a 32-bit relative branch. If you want to do move RAX, oh, what can we do? Oh shit, I don't feel like doing it. Is there anything safe we can do? We can do beep, but I don't feel like doing beep because it takes parameters. Beep takes frequency and busy. Shit. Okay. So push, busy, wait. Yeah, might as well. Just a tip, it always does 64-bit pushes. You can't, if you see it pushing 8 bits, it's pushing 64. If you see it pushing 16 bits, it's pushing 64. If you see it pushing 32 bits, it's pushing 64. A lot of the old school programmers, I gave I know how old school we all learned 16-bit real mode. We all did, our generation. There's a lot of pitfalls that you don't understand about 64-bit mode. Like, for example, pushing 16 bits and getting 64. Anyway, so push. This is the frequency. I think, did I say it's a float? No, it's not. Good. Oh, well, it doesn't matter. We could handle that. So we... Holy shit, what happened? I think I fucked something up. Oh, no. It had to calculate a simplified value for 500. It invoked just in time and then returned. The assembler has all the benefits of the compiler just in time. Okay, so here was the main point. If you want to okay, now let's say call here. Is this gonna work? Okay, it worked. Okay, so the nasty part is let's unassemble here. Unassemble here. Here's a global label. Oh, we got more than we wanted. So I pushed 1. I pushed 500. Then I loaded the address into a register, and then I called the register. That's how you have to do it if you want to do 64-bit. You know what I said? Did you notice today's computers? I had 8 gig about 5 years ago, and I didn't use it. Now I have 64 gig of RAM. You know, nobody cares. If you have they don't care. If they have 8 gig, that's nobody cares. So you know what? everybody fights the last war, like battleships in World War II, and everybody thinks memory is going to keep growing. But look, everybody's happy with 8 gig. It's not growing. You know what? My system is a toy, but even aside from that, 2 gig is enough for code. In my situation, 2 gig is enough for code. So you know what I did? I said, fuck it. We're not going to do 64-bit code addresses. So you know what? I never have to do register ugly call instructions. All my code is in the first 2 gig. It's done with a malloc. When a task needs to make some basic program in memory, it calls malloc and stores it. So there's a malloc that's coming from the lowest 2 gig, and that means that you have to be able to go 2 gig up or 2 gig down, and that's why the code heap is the lowest 2 gig. A lot of people they want to call me a liar and say, no, it's 32-bit. You lie, it's 32-bit. I don't know. I think it's just the CIA wasting my time. Anyway, so guess what? Other systems try and protect stuff from one task to another. I64 what equals 1, 2, 3, 4. Address what? So this is a global. I sort of cheated. I put the global variables into the code space. That's really bad. But the reason is, guess what? The global variables benefit from short addresses too. So when you call malloc, it comes out of the big area. Global variables, it's getting out of the little area too. I'm kind of being bad. You can set an option and it'll do from higher. But anyway, I sort of cheated. You won't notice that it's using the code heap for global variables. I64 star II equals 0x. So what is your problem? Oh, I said star, but I didn't do star. So star II. 1, 2, 3, 4. So there's absolutely no protection. There's one map. So if something is an address in one, it's an address in the other. There's absolutely it's one address space for all the tasks, and you can debug, you can poke, you can peek, you can do whatever you want. Guess what? Remember I said you inherit the symbols of your parents? All tasks, this is the Adam task. You're not allowed to type in his memory. He's the closest thing to kernel memory that you have. You can say, hey Adam, allocate a 64-bit integer and call it Cain. So this tells Adam to compile and do some code. Now I can say Cain equals 56, and over here, remember all tasks inherit symbols of their parents. So Cain is a perfectly valid symbol, 56. Cain, so this is a global variable in Adam's space. So you can make Adam do a file. It's ridiculously easy to make a DLL. If you want to make a DLL, go to your home directory. You can make home is what's called during boot, and you can see what it does. It includes the files. So there's a wrapper file, and let's say U0 my DL, how about woo hoo, woo hoo, and I64 global woo hoo. For I equals 1, sorry. Let's, might as well beep. How about let's beep? We're gonna beep. Okay, so here's what's gonna happen. This is just garbage. Okay, so we put this into this wrapper file, and it's part of the make build. The wrapper is right here, and when it reboots, it starts in the root directory, and it calls StartOS, and at the bottom this calls make home in the home directory. Guess what? If a file's not found, it searches the parent directories. So you can actually have defaults in the root directory. That's what these home files are. They're defaults. Anyway, so you can delete these and it will use the defaults. Anyway, so let's reboot. Oh shit. Okay, so if that happens, we have a hosed system, don't we? So we say fix. This does an emergency editor. Okay, I64I. Now we do escape, reboot. Now that's why you have a C and a D partition. What you can do is we could boot the D, and then we have access to the C drive, so we can fix it. Don't be alarmed, it's pretty normal. Okay, so woohoo 5. So there's a global woohoo. Maybe you thought it was hard having global variables, DLLs. So somebody thought I did not have DLLs. That's pretty laughable. As a matter of fact, I don't want third-party libraries, and the reason is because I want it to be like a Commodore 64. I want it to be innocent. I want it to be small. When you press F1, I want you to say, hey, this is all the help. I can master this. This is not that bad. I want you to see the light at the end of the tunnel. As a matter of fact, if you want to, we have a, what if the DLL wants its own global variables? Then you make a frame, and what that is you make a symbol in your table, and you can go away and come back to it. So the DLL makes a frame, makes a symbol in the table, and it can find it again if it's re-invoked. Anyway, so maybe, as a matter of fact, when you do Control R and you do make sprite and you do a mesh, okay, as a matter of fact, I have to, that's a DLL file that's making the mesh, as you can imagine. And if I do Control R, make sprite, and if I do another mesh, okay, you can see how both of these would have, these are both DLL files, and they both need their own variables. So what they do is they put a frame into the symbol table, and it takes, well, it can look it up pretty fast. It's a hash symbol table. Anyway, so as a matter of fact, we can go look at that code. I just want to, because I want to see it, to make sure I'm not crazy. Let's go find frame. There's the mesh frame, mesh frame, mesh frame, mesh frame. So once it's found, then it passes it around. All the routine, you don't want to search it in your table very often. Where is the master? You son of a bitch. Uh-oh. I'm getting nervous. There it is. So it makes a frame pointer called CMeshFrame, and that's a symbol in the table, and it has one value, and I guess that's fetching the value. It's searching for a symbol and getting the value and storing it. Why is it doing task? That's I guess that's okay. I guess that's because it's the task symbol table. So somewhere around here we're going to make the frame. There's where we make the frame, and then if we're a good boy, we even remove the frame. Yes, we delete the frame. Okay. So normally you don't delete hash table values, but with those frames I figured I better. When you include code, it overshadows what was in the table, and it doesn't remove it, because you might have dependencies on the old code. So just kill the task, Shift Escape, Control Alt T. So Control M. What else we want to talk about? Oh, that ought to be a good start. Maybe we get some dialogue.